Hello and welcome to the algorithm analysis for Atlas. Here's a high-level summary of how the algorithm works. So the algorithm basically finds a geocoded centroid that gives an array of weighted geocoded points on a map. The weights incur a bias, allowing us to find a weighted centroid. The APIs used for this algorithm include the Maps Embed API that creates a map, the Places API that searches addresses on a map and also returns a list of places near the centroid, the geocoding API that geocodes the inputted addresses. The runtime for this algorithm is ON because there's n-1 linear calculations where n is the number of points. So here's a basic overview of how it works. Let's say we have two starter points, A and B, both with weight 1. The centroid of these 2 points is quite simply the midpoint between them. So we have the midpoint AB right there. Now consider that these 2 points have different weights. Let's say the weight of A is greater than the weight of B. Then here's what happens. You notice that the point is biased towards A. In fact, it is exactly by the proportion B over A plus B, in favor of A. If it helps you visualize it, you could also consider this to be a center of mass problem. But what happens when you have multiple starter points? Well, all you have to do is simply iterate over all points. Here's how you would do that with 3 points, A, B, and C, and let's assume for simplicity's sake that they all have weight 1. First with A and B. We get that midpoint AB, and this has the weight of A plus the weight of B, so that has the weight of 2. Now between AB and C, notice how there's a bias towards AB since it has the larger weight by the ratio of 2:1. And our point ABC is our centroid with weight 3. Now bringing this idea to the third dimension, that too on a sphere, proved to be challenging. The first thing we needed was a geocode. And here's where our APIs come into play. So entering an address into our search box does 2 things. So it uses the Places and Maps Embed API, and a marker is placed on the location specified. And using the geocoding API, we find the geocode of the location. Then we append it to an array that takes latitude, longitude, and weight. And in our case, the default weight is set to 1. Having our array of geocodes, we use the formula that takes 2 geocoded locations and finds their midpoint. This is applying the concepts of the great circle length and finding the angle between these 2 points on the great circle. Where a 2D circle would use sine and cosine formulae, our 3D rendition of the algorithm uses the Haversine and the cosine of spheres formulae. Manipulating the algorithm to account for weights, we now have a formula that finds the central location between any 2 weighted points. Now all we did was iterate it over each point on the array, updating the geocodes and weights of the points as the algorithm is applied to 2 points. And here's a satisfying animation that shows how that loop works. At the end of it, we get a geocoded centroid. Now we simply mark it on the map and return a whole list of things to do within a default of 500 meters radius using the Places API. And that's how the algorithm works.